بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 4.3, the Simplex method, maximization. First, we will talk about unique solutions, and we will consider here only in this section the standard maximization problems. And for the standard maximization problems, we have three conditions. The objective function is to be maximized. So the question is maximize, not minimize. All variables are non-negative. So x1, x2, up to xn, all are positive, greater than or equal to 0. The constraints are of this form, less than or equal to a positive number. Okay, all the constraints should be less than or equal to a positive number. So greater than is not okay. And if b is negative is not okay. It will not be in the standard form. It will not be a standard maximization problem. So we will talk only in this section about standard maximization problems. There are three tasks to do in the Simplex method. Task A, set up the matrix for the Simplex method. So we need to set up the matrix for the Simplex method. So let us talk about this task. First, we have a problem like this. Maximize this objective function subject to these constraints, and all the constraints are less than or equal to a positive number. And all variables, of course, are greater than or equal to 0. So first step is to introduce slack variables, different slack variables, a slack variable for each inequality. X plus 2y is less than or equal to 10. So there is a number, a positive number. If you add this number to x plus 2y, then x plus 2y plus s1 would be equal to 10. For example, x plus 2y less than or equal to 10. It could be 8, for example. So s1 would be in this case 2. So 8 plus 2 would be equal to 10. So we introduce these slack variables, s1 for objective for constraint 1 and s2 for constraint 2. So 2x plus y plus s2 equals to 14. So this is the first step. We introduce two different slack variables, positive positive numbers s1 and s2, such that we have two equations now. And the third equation is the objective function. We write it as an equation with 0 in the right hand side. So we take 2x and 3y to the left hand side, and we write it like this: negative 2x minus 3y plus f equals to 0. The second step is to write these three equations in a matrix called the initial simplex matrix, in which we put the variables starting from x, y, then s1, s2, the slack variables, and f, the objective function. And we put the coefficients of each of these variables from equation 1. Coefficient of x is 1, coefficient of y is 2, coefficient of s1 is 1. There is no s2 in the first equation, so the coefficient is 0. There is no f in the first equation, so the coefficient is 0. And the constant term or the constant number is 10. Also, we do that for the second equation and for the third equation, the objective function. Coefficient of x is negative 2, coefficient of y is negative 3. There is no s1 and s2, so the coefficients are zeros. The coefficient of 1 is 1. At the right hand side is 0. So between the right hand side and the other columns, we put a vertical bar and we put a horizontal bar between the constraints and the objective function. So now we finished task A. So task A is to set up the matrix for the Simplex method. We first introduce slack variables and then we set up the matrix. Task B is to determine the pivot elements and the necessary row operations with the pivot rows to reach a solution. So in task B, we do pivoting operations to reach a solution. Well, how to do that? First, we find the pivot entry or the pivot element in this matrix. And to determine the pivot element, we first determine the pivot column. And the pivot column, to determine the pivot column, we look to the objective row, the last row, and we search for the most negative entry, which is -3 in this case. So this column would be the pivot column. So it's simple. You go to this matrix, look to the last row, the most negative number will determine the pivot column. Good. What happens if I have, for example, -2 and -2? Two numbers, same numbers, -2 and -2, or -3 and -3. In this case, we have a tie, and any of the two numbers would be okay. If tie occurs, use either column. Any of the columns would be okay. Okay, this is how we determine the pivot column. Now we need to determine the pivot row, and the pivot row would be either the first or the second row. The objective row is not a possibility, is not a choice. Okay, so either it's the first or the second. How to determine? We divide the constant term, or the right hand side, 10 by 2, by the number in the pivot column, 14 by 1. Okay, and the smallest result, 5 here in this case, will determine the pivot row. So the pivot row in this case is the first row. There is an important point. 2 and 1 have to be positive numbers. Okay, so we divide by the positive coefficients in the pivot column, the positive coefficients. If there is uh, a tie, okay, if it's 5 5, if the answer is 5 5, then we choose any of the two rows. Okay, if there are no positive coefficients in the pivot column, so for example, this is -2 and this is -1 or 0, okay, or both are zeros, so then there will be no solution, to the problem, and we will stop here. So since the two numbers are positive, we divided 10 by 2, 14 by 1. The smallest is 5, so that this is the pivot row and this is the pivot column. So the pivot entry is 2, or the pivot number. The pivot entry is 2. All right. So now we determined the pivot entry in this matrix. What to do with it? Well, we change it to 1. We make it 1. How can we make it 1? We make the pivot entry 1. How? We divide by half. We divide by 2, or we multiply by half. Once we divide by 2, we will get 1. Then we use this 1, okay, the pivot entry, now it's 1. We use it to make these two numbers, 1 and -3, zeros. So we need to have the column, this column, 1 0 0. Notice that here in this matrix, I have 1 0 0 0 1 0 0 0 1. These three variables, S1, S2, and F, are called basic variables. Any variable with 1 0 0 or 0 1 0 or 0 0 1 is called the basic variable. So in this matrix, we have three basic variables and two non-basic variables. All right. So now we are really changing y, because this is the column of x and this is the column of y. This is S1, this is S2, and this is the column of f. So we are making y a basic variable. And one of the old basic variables will be non-basic after this pivoting operation. So we have 1 0 0. We got 0 here by adding -1 times the new row 1 plus row 2, and 3 times new row 1 plus row 3 to make 1 and -3 zeros. So now we have this new matrix. Now, is this the last matrix? Is it the final matrix? And the answer is no. Why? Because one of the indicators, and indicators, these numbers are called the indicators, okay, without the 15. The 15 is not one of them. So the numbers in the objective row, in the last row, are without the 15, are called indicators. If all of these numbers are positive or 0, then This is a final matrix and there is a solution. But if one of them is negative, then we have to do another pivoting operation, uh, another pivoting operation. Notice here in this matrix, the maximum value of f is 15, okay? And there are three basic variables, y, s2, and f, and two non-basic, x and s1, okay? So I can read a solution here, but it's not a final solution because still negative half is negative. So let us change, let us find the pivot entry in this matrix. What is the pivot entry? Now this is negative half, so this is the pivot column. Okay, this is the pivot column. And now these two numbers are positive, so we divide 5 divided by half, 9 divided by 3 over 2, and 6 is the smallest. So this row is the pivot row. So 3 over 2 is the pivot entry. We make it 1. We multiply by 2 over 3, and then we use it to make half and negative half zeros. So we will get this new matrix. Now look to the indicators. All the indicators are 0 or positive, so no negative numbers. So this is a solution. There is a solution here. The basic variables now are x and y because we have 0, 1, 0, 1, 0, 0, 0, 0, 1, f also. And then, but yeah, f is the objective function. And the non-basic variables are s1 and s2. So f is not really considered basic or non-basic because it will be always 0, 0, 1. It will be always there. The change happens with x, y, and s1 and s2. That we can read. This is task B. We finished now task B. Let us go back to task B. Determine the pivot elements, the necessary row operations with the pivot rows to reach a solution. We reach the solution now. And task C, read the solution. Okay, what would be the solution? And the solution would be, you can, if you want, you can write here now the three equations. Now this is x, this is y, this is s1, this is s2, and this is f. So the first equation would be y plus 2 over 3 s1 minus 1 over 3 s2 equals 2. And the second equation would be x minus 1 over 3 s2 s1 plus 2 over 3 s2 is 6. And the last equation is 4 over 3 s1 plus 1 over 3 s2 plus f is 18. Now to read the solution, we put the non-basic variables, we set the non-basic variables equal to 0. So S1 and S2 here non-basic, so they would be 0. And now you can read the solution. F is 18. The maximum value of F is 18. And it occurs when Y is 2 and X is 6. You read it from here. So Y is 2 and X is 6. And S1 and S2 are zeros. So this is the answer of this problem. Let us solve an example. Let us start with task A. In task A, we introduce slack variables. And we write the objective function like this, keeping the right hand side 0. And then we set the initial matrix, initial simplex matrix. Coefficients of x are 1 to negative 4. Coefficients of y are 2, 1, negative 3. Coefficients of S1, 1, 0, 0. S2, 0, 1, 0. F001 because there is no F in the first two equations. And now the right hand side 8, 10, 0. And this is the initial simplex matrix. And we finished task A. Now let us start task B. Well, task B would be determine the pivot entry. So to determine the pivot entry, we look at the last row, objective row. This is the most negative number. So this is the pivot column. Now 8 divided by 1 is 8. 10 divided by 2 is 5. So this is the pivot row and 2 is the pivot entry. Now we need to make 2 1 to make x as a basic variable now. So we will make 2 1 and we will use it to make 1 and negative 4 zeros. So to make it 1 I will divide by 2. So I'll have 1 2 1 0 0 8 and 1 half 0 half 0 and 10 over 2 is 5. This is not a simplex matrix. This is something in the middle, okay? And the last row as it is, because it's difficult to make this step in one at once. I have to do it in two steps like this. But put in your mind that this is not a matrix. It's just a step in the middle. Now I will reach the matrix. I have 1 half 0 half 0 5 in the second row. Second row is not changing. And now this one has to be 0. So negative R2 plus R1 will make it 0. This is the pivot entry. So we use it to make this one 0. And to make negative 4 0, 4R2 plus R3. So negative 1 plus 1 is 0. Negative half plus 2 is 3 over 2. Negative 0 plus 1 is 1. Negative half plus 0 is negative half. This is 0. Negative 5 plus 8 is 3. Now 4 times 1 plus negative 4 is 0. 4 times half is 2 minus 3. This is negative 1. 4 times 0 plus 0. 4 times half is 2 plus 0. 4 times 0 plus 1. 4 times 5, 20 plus 0, 20. So this is the new matrix. This is the new matrix. Is it a final matrix? The answer is no, because we still have negative 1 here. So this is the new pivot column. And now divide 3 by 3 over 2. The answer is 2. Divide 5 by half. The answer is 10. So this is the pivot row and the pivot entry is 3 over 2. And now we need to make this number, which is 3 over 2, I need to make it 1. So how to make it 1? I multiply first by 2 over 3. It is the pivot entry. Multiply by 2 over 3. 2 over 3 times negative half. Please always use the calculator not to make mistakes. Then 0. Then 3 times 2 over 3 is 2. And the second row as it is. And the third row as it is. And keep in your mind that this is not a new matrix. This is something in between. And now I need to make half and negative 1 zeros. So negative half R1 plus R2 and R1 plus R3. And now I'll have a new matrix. in which the first row is as it is, and now these two transformations will not change 1 and 0 because this is 0. Negative half plus half is 0. Negative half times negative half times 2 over 3 is plus 0. So this is negative 1 over 3. Okay. Now negative half times negative 1 over 3, 1 over 6 plus half. And that's 2 over 3. And this is 0. It will not change anything. And negative half times 2 is negative 1 plus 5. That's 4. Now, R1 plus R2, 0 plus 0. R1 plus R3, sorry, 1 plus negative 1 is 0. 2 over 3 plus 0 is 2 over 3. Negative 1 over 3 plus 2 is 5 over 3. 0 plus 1, 2 plus 20, 22. And this is a new matrix. And the question, is it a final matrix? And the answer is yes, because all the indicators are positive. So now the last task C, read the solution. Well, if the maximum f is 22 at, now this is x and this is y. So x here, this is 1 times x, so x would be equal to 4. And y, this is y, the one here, equals to 2. And these are the two basic variables. And S1 and S2 non-basic variables. So we set them to 0. So S1 and S2 are zeros. X1, X is 4, Y is 2. That's the answer. And of course, you can check that answer if you replace X here by 4. 4 times 4, 16. 3 times 2, 6. 6 plus 16 is 22. So that's fine. This is the answer of this question. Checkpoint. Write the following constraints as equations by using slack variables. All right. So the first equation would be 3x1 plus x2 plus x3 plus s1 equals 9. The second, 2x1 plus x2 plus 3x3 plus s2, the second slack variable, equals 8. 2x1 plus x2 plus s3 equals 5. So we introduced the slack variables. Set up the matrix to maximize this objective function. Let us write it. Negative 2x1, negative 5x2, negative x3 plus f equals to 0. So we can set up now the matrix. The coefficients of x are 3, 2, 2, and negative 2. Coefficients, this is x1. Coefficients of x2 are 1, 1, 1, and negative 5. Coefficients of x3, 1, 3, 0, and negative 1. Coefficients of S1, 1, 0, 0, 0. Coefficients of S2, 0, 1, 0, 0. Coefficients of S3, 0, 0, 1, 0. F, coefficients of F, 0, 0, 0, 1. The right hand side 9, 8, 5, and 0. And this is the initial simplex matrix. Now using the simplex matrix, perform the following. Find the pivot, the first pivot entry. Well, the most negative is -5, so this is the pivot column. And now 9 divided by 1 is 9, 8 divided by 1 is 8, 5 divided by 1 is 5. 5 is the smallest, so this number is the pivot entry. So the pivot entry, if I call this matrix A, then the pivot entry would be 1, 2, 3, third row, second column. So it is A, 3, 2, which is 1. Okay, that's the first pivot entry. Use row operations to make the variables of the first pivot entry basic. Okay, so we want to change now x2 to a basic variable. So it is 1 already. That's nice. So we will use it to make the other numbers zeros. So what are the transformations? Negative R3 plus R2. Negative R3 plus R1. 5R3 plus R4. So let us write the third row as it is. The numbers in the third row are 2, 1, 3 zeros, 1, 0, 5. All right, the first row. -2 plus 3 is 1. -1 plus 1 is 0. These numbers I have here zeros. These are zeros. So the numbers below and above them will not change. So I have here -1, 0, 0, and 3, 0, 1, and 1, 1, 0. So -1 plus 0 is -1. And also this is 0, so it will not change anything. So I have 0, 0, and 1. And now -5 plus 9 is 4. And we finished from the first row. The second row also -R3 plus R2. -2 plus 2, that's 0. -1 plus 1 is 0. And -1 plus 0 is -1. And -5 plus 8 is 3. Now the last row, 5R3 plus R4. 5 times 2 is 10 minus 2, that's 8. 5 minus 5, that's 0. 5 times 1, that's 5 plus 0. 5 times 5 is 25 plus 0, so 25. And now the pivot, uh, the new maximum value of f. Notice that in the first row, f was 0. And this happens at the corner point when x1 0, x2 0, x3 0. Because they are non-basic variables in the first matrix. And the non-basic variables, we set them zeros. The basic variables are S1, S2, S3, and F. So this is the first value. And it's in fact a corner point, 0, 0, 0. Now we move the simplex method. Each new matrix will move you from a corner point to another corner point. So here the basic variables are this one, this one. Of course, f is always there, and this one now. So x2 is a basic variable, s1 and s2. So x2 here is 5. So when x2 is 5 and x1 and x3 are zeros, then f would be 25. And you can check that in the original equation. If x2 is 5, x1, x3 are zeros, then f would be 5 times 5 is 25. So you can check somehow that this in the each simplex matrix, the objective function is satisfied, and we are moving from a corner point to a corner point. So the corner point here is 0, x1, 5, x2, 0, x3. This is a corner point of the graph. So that's the idea of the simplex method. Okay, is it a final matrix? No, it's not a final matrix because we have a negative number here. So what is the second pivot entry? Well, I have no look, I have 0 here. So I have 0 here. So only the pivot row would be the first or the second. The third is no possibility. So 4 divided by 1 is 4. 3 divided by 3 is 1. So this is the second pivot entry. This is the second pivot entry. And if I call this matrix B, okay, then I am in the second row, third column. So I will call it B23, and it is the number 3. So 3 is the second uh, pivot entry. Now we do what? We make it 1. So I will divide by 3. So I will have, let me write it here. I will have 1, 0, 1, 1, 0, negative 1, 0, 4, and now 0, 0. 3 divided by 3 is 1, 0, 1 over 3, negative 1 over 3, 0, 3 over 3 is 1, 2, 1, 0, 0, 0, 1, 0, 5, and the last row 8, 0, negative 1, 0, 0, 5, 1, and 25. This is not a matrix, which means you cannot talk here about a basic and non-basic or a maximum or a solution. No. You have to write now what is the pivot entry. The pivot entry is this number now, and we need to use it to make this 0 and this 0. So negative R2 plus R1, and here R2 plus R4. So we will have a new matrix, the new matrix now. The second row is not changing. And these are zeros, so the numbers below and above will not change. Also, this is 0, so also here I have 0. Okay, and now negative 1 plus 1 is 0. Negative 1 over 3 plus 0. 1 over 3 minus 1, and negative 1 plus 4. Okay, there is no change in row 3. There is a change in row 4. Negative 1, no, I just add R2 plus R4. 1 minus 1, 0. 1 over 3. Negative 1 over 3 plus 5. 14 over 3. 1 plus 25 is 26. And we reached now a final matrix because all the numbers, all the indicators are positive, and we can read the solution. The maximum value of f, is it f? Yeah, it is called f, is what? Is 26. Where does it occur? Now, what are the basic variables? This is a basic variable, this is a basic variable, this is a basic variable. So x2, x3, and s1 are basic variables, all right? And also f here. So we put x1 0 because it's non-basic, and s2 and s3 zeros. Then x2 would be equal to 5, x3 is equal to 1, and s1 is equal to 3. So that's the answer. x1 is 0, x2 is 5, x3 is 1. Let us put it in the equation to make sure. 0, 5, 1. 0, 5, 1. 25 plus 1 is 26. Yes, if 0, 5, 1, then the maximum value of f is 26, and that's the corner point 0 to 1 in which this maximum occurs. Now let us move to the case when non-unique solutions, either multiple solutions or no solution, could happen. Multiple solutions. How can we find out that the problem has multiple solutions? If we have a non-basic variable with a zero indicator in its column, then there may be multiple solutions giving the same optimal value for f. We can discover whether another solution exists by using the column of the non-basic variable as the pivot column. So look to the non-basic variables here in this matrix. x1 is a non-basic variable. The indicator is 8. s2 is a non-basic variable. The indicator is 1 over 3. s3 is a non-basic variable. The indicator is 14 over 3. So none of the indicators is 0. But if one of the indicators is 0 for a non-basic variable, then there is a possibility that there are multiple solutions. Okay, and we can use the non-basic variable, the column of the non-basic variable, as the pivot column. So let us take this example. Let us introduce slack variables x plus half y plus s1 is 16, x plus y plus s2 is 24, and let us write the objective function in the form uh, in this form. And now let us set the initial matrix. So 1, 1, negative 2, half, 1, and negative 1 coefficients of y, s1, s2, and f. The right hand side, this is the initial matrix. Let us determine the pivot entry. The most negative is this one. 16 divided by 1 is 16. 24 divided by 1 is 24. 16 is the smallest. So this is the pivot entry. Use it to make 1 and negative 2 zeros. So negative R1 plus R2, 2 R1 plus R3, and we will reach the new matrix. Well, the first row as it is. And now let us find the second row. Negative 1 plus 1 is 0. These are zeros, so let me write the numbers below and above. Okay. Negative half plus 1 is half. Negative 1 plus 0 is negative 1. Negative 16 plus 24 is 8. The last row. 2 plus negative 2 is 0. 2 times half is 1 minus 1, that's 0. Uh, 2 times 1 plus 0 is 2. 2 times 16, 32. Now, is this a final matrix? And the answer is yes, because all the indicators are positive or zeros. So we have a final solution. So maximum value of f, yeah, it is f, of f is 32, and it occurs when x and y. X is a basic variable, so x is 16. Y is non-basic. Okay, so y is 0. Uh, S1 is non-basic, so we put it 0. And S2 is basic, so S2 is 8. Okay, so the basic variable takes the number in the right hand side. Now the corner point here is 16 and 0, but we notice something. Now S1 y S1 uh, is 0. I mean, where are the non-basic variables? Non-basic variables, non-basic variables are y and S1, the one we set to 0, S1 and y. Look to the indicator of S1, it is 2. What is the indicator of y? It is 0. So the indicator of y, which is a non-basic variable, is 0. So this means that this problem may have multiple solutions. How can we find another solution? Okay, we make this column now would be a pivot column. So 16 divided by half is 32. 8 divided by half is 16. So this number could be or is the pivot entry, and we can make it 1 by multiplying the second row by 2. And the last row as it is. This is not a new matrix. This is the number in the middle. This is now the pivot. We need to make the half 0. This is already 0. So negative half R2 plus R1. And now we will have a new matrix. There is no change in the last row. Also in the second row. And now negative half plus half, that's 0. Negative half times negative 2 is 1 plus 1, that's 2. Negative half times 2 is negative 1 plus 0. And negative half plus 16 is negative 8 plus 16 is 8. And now this is another final matrix. This is another final matrix. Okay. And uh, we can see that the non-basic also the maximum of f is 32, the same maximum. It happens in at another corner point now. Now x is basic variable and it's 8, and y is a basic variable and it's 16. and now S1 and S2 are zeros. Okay, S1 and S2 are zeros. So is it a possibility? Yeah, 8 x8, 8 times 2 16 plus 16 32. So that's a solution. And also here, if x is 16, 2 times 16 32 plus 0. So both are solutions, both give maximum value of f, and also all points between them will give the same. Between these two corner points will give the same answer. So here we have a multiple answer, multiple solutions. Not only two, we can find more, infinitely many solutions. The last case, when there is no solution, how to know from the matrix that we have no solution? We mentioned this in the beginning. We said that the pivot entry, when you determine the pivot entry, all the numbers above or and below in the constraints would be negative or zero, so you cannot continue. Let us see this uh, problem. Maximize if a maximum exists. So let us introduce slack variables. x1 minus 3x2 plus x3 plus s1 is 3x1 minus 6x2 plus 2x3 plus s2 is 6. And let me write the objective function in this form: negative 2x1, negative 2x3, negative 3x3 plus f is 0. And let us set up the initial matrix. Coefficients of x. x1, coefficients of x2, coefficients of x3, coefficients of s1, coefficients of s2. Notice here that coefficients of f, there are three variables, but two equations, two constraints. So there are two slack variables. So the number of slack variables depends on the number of constraints. All right. Now, how many basic variables? There are two with f, of course, and three non-basic. So the number of basic variables would be always equal to the number of constraints. All right. Where is the pivot column? Negative 3 is the most negative. Okay, 3 divided by 1 is 3. 6 divided by 2 is also 3. So I can choose whether the pivot entry is 1 or 2. Of course, I'm going to choose it 1 because it's easier, because it's already 1. I just need to use it to make 2 and negative 3 0. So negative 2 R2 plus R1 and 3 R2 plus R3. And let us see the new matrix. All the zeros will not, okay. The second, yeah, both will change. Okay, negative 2 R1, negative 2 R1 plus R2. So negative 2 plus 1, negative 1. Negative 2 times negative 3, 6 minus 6, that's 0. Negative 2 plus 2, that's 0. Negative 2, negative 6 plus 6, that's 0. Okay. 3 plus minus 2 is 1. 3 times negative 3 is negative 9 minus 1, that's negative 10. Negative 9 plus minus 1, negative 10. 3 plus minus 3, that's 0. 3 plus 0 is 3. 3 times 3 plus 0 is 9. And this is the new matrix. And you can check here that we have uh, how many we have. Now, if you go to the next, if you want to find the second pivot entry, this is the pivot column because this is the only negative number. But these two numbers are one of them negative and one of them zero. So I cannot use a pivot row. So there is no solution. This problem has no maximum. It could have a minimum, but it has no maximum, okay? Because x2 plus x3, if you add these numbers again and again, and you will get always maximum more than any choice you make. So whenever you cannot continue to find the pivot entry, you stop and you say no solution. That's the end of the section. Hopefully, it's clear with you.